Okay, hello everyone. Let's get started. My name is Fitz. I am a developer advocate with Temporal Technologies. And I'm here to talk to you about actors and workflows, how they are both same and different, and the way we are going to go about creating that once the slides come back up is through a customer loyalty workflow. So our goal here is to build something that looks like a customer loyalty workflow. And what I mean by that is, suppose you have a program where people can earn points, they can be promoted to different statuses, they can maybe get benefits like inviting other people to join and share their status. That is the program that I want to build here. And my question to you is, how would you go about building that? Because typically, you might say things like, well, I've got my customers, obviously, those exist. They are out there, and they're probably going to interact with my service in some way via, we have some login providers, we have some load balancing. We're not going to talk about those things. But after that, we end up going to some sort of event stream processor to manage those incoming things like a user has taken another ride, they've earned some more miles, some sort of message processor to handle these things coming in. We have a collection of consumers to actually do things with those messages, and then of course we have some databases to go and store things to, get things from, things like that. Now I see something like this and it looks simple, but it's never this simple, right? There's always extra things that have to go along with this. We end up having more message processors, more message queues, external pollers to make sure that our consumers are working okay. We have to segment things such that everything works out properly when our consumers die, or when our databases die, or when we need to scale things out. It's never this complicated, or never this simple, right? It's always more complicated. What I would really love is an interface that looks like this. Right? I would love it. It's super simple. I have a customer. I can add points to them. I can invite guests. I can cancel the account. I can get their status. That's it. That's all I really want. Now, this is where we start talking about something called the actor model. And we're going to talk about that. We're going to define a couple of terms there. We're going to segue into talking about what workflows are. I'm going to define that and define them specifically how we want to define them, such that we can combine the two and have workflows acting as actors. Before I get into it, I want to check with everyone here. Who here is familiar with the actor model? Okay, about third of the room maybe. Excellent. For the rest of you, we're going to define these formally. This was a computational theory developed in the 70s, specifically in the context of artificial intelligence, and they were defined formally as: we can send and receive messages to actors, actors can create other actors, and actors can modify their own state. That's the formal definition of what an actor is. Now, when I see this, when I first read this, I immediately thought of something else that Java has in plenty, right? Objects, right? These are basically just objects. They are things that have methods, can call methods, can have their methods be called, they can create other objects, they can maintain their own state. Right? So whenever I mention actors, I want you to also think about objects, because they are basically the same, right? They have the same properties, they have the same guarantees, and it's just another term for them, essentially. But when we look at starting to implement them, there's a few other things that we want to consider. So first, sending and receiving messages. What does that really mean? Well, we need to be able to know the addresses of the other actors. If we are just implementing objects, that's the simple reference that we have to the other object. If we want to send it to an actor, we're going to have a little bit more. We need to be able to act on those messages, and really, in order to gain the most benefit out of them, we want to be able to act on them asynchronously and in any order that they come in. Those last couple of things, asynchronously and in any order, make me think of parallelism and concurrency. So another level set, who here is very comfortable with the difference between parallelism and concurrency? Not a single hand. Lovely, because I have a slide on that. Parallelism and concurrency. These are terms that are very often combined with each other, conflated, interchanged, and confused. They are used in almost the exact same context all the time. Parallelism is the idea of literally doing two things at the same time. So I can walk and talk at the same time. I'm doing those in parallel. Concurrency is organizing and designing things such that I'm able to do different things independently from each other. So I have one process that is waving my hands, and I have a different process that is talking. These are two very different things. So I often have these happening at the exact same time. Parallelism, in order to do that without having too many locks and too many deadlocks and too many conflicts, I end up designing my system to be highly concurrent, such that there's nothing standing, no processes or no threads trampling on each other while they run at the same time. So I implement concurrency in order to make parallelism easier. Parallelism we also get by default in just standard operating environments. We have our operating system, I have my browser, and I have IntelliJ open at the same time. Parallelism, they're concurrent by nature because they're entirely different things. That's parallelism and concurrency. And when we get to the actor model, I'm now going to ask another question and ask you to raise your hands. For the actor model, based on what we've defined so far and what you know about it, is the actor model parallel? Raise your hand if you think it's parallel? Got one or two. Raise your hand if you think it's concurrent. I got a few more. Raise your hand if you think it's both. Okay, so for those of you who thought it was both, congratulations. Your loyalty status has been promoted to platinum status. You are now able to reap all of the benefits of our customer loyalty program. Because in order, again, to maintain the most benefit out of this model, we need to be able to run many of them in parallel, and similar to objects, we, by nature of this pattern, get concurrency by having very separate entities. Actor A and actor B can only interact with each other through messages. They don't have any shared state between the two of them. Okay, so that's two of our three things. We have sending and receiving messages. We can act concurrently and in parallel. And I'll add one more that may seem obvious, but in order to be able to act on messages, in order to be able to receive them, and in order to be able to maintain state, I need to exist. So when I start looking at an implementation standpoint, I need something that exists in order to actually handle those messages. In that initial architecture diagram I showed, it was those consumers plus the event stream processor. But as we get into it, we're going to talk about how that looks like a workflow. The point of all of this is that we exist in distributed worlds. We can't implement anything these days without having a distributed system. We have multiple nodes across multiple clusters, across multiple data centers, because we are a global application. Even just having a single web server, we have multiple web servers. We're load balancing between them. We are in a distributed space. The actor model, by nature of providing that concurrency, that separation of concerns, and that separation of being able to isolate each other so they can act independently, that helps get a lot of our distributed systems problems a lot easier. We don't have to worry too much about leader election, two-phase commits, or any of the other complex distributed systems algorithms that we don't want to worry about. That said, there are definitely challenges in this model that always are going to arise. First, in order to really get, well, actors are not quite useful if they are entirely stateless. I think a lot of people, myself included, have tried to implement completely stateless architecture, completely stateless things, and inevitably I need some kind of state somewhere. Our actors, one of those requirements of actors, one of those three requirements was I can maintain state and therefore change how I respond to messages based on that state. And so if I want to have that, how do I actually maintain that? Where is that state stored? And in particular, if it's stored just in memory and things crash, it's now lost, right? So I need some kind of process to be able to persist that state. Now, with most actor models and most implementations of that, when I crash, things die, and come back up, recovering that state such that we are back to where we need to be able to handle new messages is never a simple process, right? Especially if we look at that initial architecture diagram that I had at the beginning, where I have the event stream processor, the consumers that are storing some state in the customer database. If I have that customer database around, it's normally the latest status, right? I have this customer has this name with these many points and this status tier, but I don't know how they got there. That can sometimes be a problem if I need to go backwards, or if I need to be able to have an actor that knows how it got to where it came from, depending on what your use case is. So knowing now that recovering state into an actor sometimes requires re-executing a series of steps to get back to where we left off, that starts to lead me into the notion of a workflow. So when we look at workflow, that word initially doesn't mean much to me in the context of actors. An actor is a thing that exists that can receive messages and send messages to something else. The word workflow does not mean that. It means the sequence of steps through which a piece of work processes from initiation to completion. It's a sequence of steps that go from start to finish. That implies a finish, and if I have an actor that wants to exist, then maybe it shouldn't finish at all. So at first, this is not really intuitive, this idea of workflows and actors being able to work together. But we're going to try to make that work anyways. We're going to try to get this thing called a workflow to act as an actor. And in order to do that, we're going to look at a technology called Temporal, which is a implementation of workflows. And the three requirements that I outlined here, being able to send and receive messages, being able to create other ones, and exist for some amount of time, I'm going to show in the course of writing the code here how we can make that work for workflows as well. And make sure I have my timer open. Yes. Okay. Reminder that we are here to create a customer loyalty workflow where we have points coming in, we have status tiers that we can be promoted to or not, depending on how many points we have. We are going to go from here into actually writing some code. If you would like to follow along, that QR code will take you to my GitHub page, which has the code. Now, obviously, this is written in Java. For Temporal, we can write code in PHP, TypeScript, Java, Python, Go, .NET, and Ruby. So if you are experimenting with any of those languages, you are able to do that with Temporal as well. This is obviously in Java. Let's get into it. This is our code for building a customer loyalty program. So here on the right, I have a very simple data object, which is just the data that represents a customer. Name, customer ID, contact information, the status that they're currently at, how many points they have. That's it. That's the entirety of that object. It just has a bunch of getters and setters. That's it. There's nothing more to that one. I then also have the interface for my workflow. I have an entry point up here at top, which is the function that is just going to run the entirety of this customer's loyalty. And then I have the what are called signals in Temporal for being able to send messages to this workflow. I can add some points to them. I can invite people. I can ensure that they have a particular status. And I can cancel the account. All right. So I'm going to run things just to get things started. And as in all things, I need something around to actually run the code. It's now running, and I'm going to start off this customer. This customer conveniently named 123, so it's easy to identify. I now have a customer that is running. We see in the logs that we're sending an email, but also in our user interface, this comes built in with Temporal. This is not something that I built. We see that there's now a workflow of 123 running, And here is the sequence of events. Again, if something that is important is being able to recreate that state from wherever it left off, I get that automatically with temporal. We're going to see more of the code here in a second to see things like, well, here was my welcome to my loyalty email that was sent. Now, it's a demo, so the email just printed out to the logs, and that's it. I didn't actually send an email, but delegate to whatever email provider you want, and I sent that message. I have it on auto refresh, so it just went away. But otherwise, we're just sitting here waiting. There's nothing else happening. We're just, at the top, you can see here that this is still running. And as an example, I can say then, let's add some loyalty points. So to that same workflow, customer 123, I'm going to add 5,000 loyalty points to make sure that I'm at a proper status to be able to add and invite guests. And we can see also in the logs that I have been promoted to Platinum tier. And in the user interface, I now also see, if we switch to compact view, that I have also sent that email. So now I have this notion of, well, I've got this record of events that these emails have been sent. I have the record of event that these 5,000 points have been added to this customer. In the logs, we will see here that I've added 5,000 points to the customer. I've promoted the customer to a new status. That status required a welcome email. Okay, now let's simulate something bad happening. So we have our process and our system running in a Kubernetes cluster, running in some data center that loses power. The cluster goes away. We have a process somewhere else that is going to migrate that to a different data center so that we can come back up. You know, our multiple availability zones are working as we intend it to happen. But in the meantime, everything has crashed, everything's gone away, and I'm simulating that by just Control-C canceling that process. That's gone. Everything that was stored in memory is now gone. I'll go back to the temporal user interface. It still thinks things are running, and I'm going to restart my worker because naturally my data center has come back up and my cluster is good to go. And you'll notice that none of my log messages have replayed. I've not re-added those 5,000 points. I've not resent that email, but everything is still here running perfectly fine. It thinks I'm running, and if I wanted to add even more points, I now get more points there. My customer loyalty points are now 10,000. I get a new event here that I've added more points, so that's the same workflow that is still running. And if I want to query that my status is Platinum still, minimum points required for that was 5,000. That's all good. Everything here is still running perfectly fine, even though I completely restarted my execution environment. Okay. That's that. I'm going to terminate this so that we can start from a clean state, because we're going to make some changes here. But before I go there, that has shown our step one, our first requirement of actors. We can send and receive messages. Now, this workflow interface has shown that we can send these signals, like add our loyalty points. The implementation of that, I had this hidden over here, but we look at that, there's nothing special happening here. So on the left here, this is the implementation of the add loyalty points function. If you look closely at it, there's not much happening. I modify that data object to add the proper points. I check to see if that warrants promoting them to a new tier, and that's it. If I need to send an email, I'll do that, but otherwise, there's nothing special here. This is just general code. Okay, that's our sending and receiving messages. So first check mark, all good to go. Next check mark is going to be creating other actors and other objects. So if our status warrants, we can invite other guests in order to invite them to our program. And here's that message for doing that. Here I have an invite guest message that I can receive. I can add them to my in-memory notion of what my guests are, just so I have a notion of how many I've added or not. Then I want to be able to create a new workflow. And a couple things happening here that I want to point out. First, I am making sure to create this such that I know exactly what address to send those messages to, should I want to send a message to my guest. This is just simply setting a workflow ID format. It's just a format string that I'm formatting with the customer ID because I like to keep things simple. That's all that is, but that allows me to clearly know which workflow to send my message to. So because I have this notion of being able to restart things, I lose that in-memory notion of things, but that series of events is going to recreate things such that I can still be able to say, well, my guests are ABC and XYZ. I can recreate those IDs and those addresses to be able to send other messages to. The second thing that I'm doing here is this close policy. That parent close policy is saying that should this workflow, if this workflow represents customer 123 and they choose to close their account, I don't want any of their guests' accounts to also close. So I want their guest accounts to still stay around even if customer 123 closes their account. This policy says any new workflows that are created from this policy should continue to exist even if this one closes and goes away. All right? Now that I've configured how to create this, I'm going to start those workflows, or that child workflow. This bit of code is saying that I want to asynchronously start that child, so I don't care about waiting for it to finish or waiting for it to finish its work. Because my entry point up here for this code just sits on a while true infinite loop, waiting for new messages such as my account has been canceled. So if I do a blocking call to this child, it is going to block forever and restrict that account from being able to receive new messages. So I want to do that asynchronously. So I want to have these two different workflows happening in parallel. Then I do a little bit of checking to see if that guest account already exists. Because if it does, I don't want to recreate it. I just want to say, great, it already exists. You are part of the program already, and you are good to go. So I swallow those exceptions that those workflows already exist, because that's a good state for us. We want them to already exist. That's our goal. But if they do already exist, I then want to send a message to it to say, well, I have defined my loyalty program such that if I invite someone to the status program, I want them to have at least my status -1. And so if their account already exists, and say they haven't used their account in any way whatsoever, they're still just the lowest status possible, but I'm platinum status, and I'm inviting them in, I want them to have gold status, which is what I've defined as the tier right below platinum. And so then I send them a message, and I send the guest a message and say, well, I would like you to ensure that your status is at least whatever the previous status of my current status is. That method, that ensure minimum status method, just as a point of reinforcing things, this is not doing anything special. This is just generic code again. You can see that I'm going through and saying, well, what should my minimum status be based on the number of points that I have? Let's set those points. Let's set that status. There's nothing about temporal. There's nothing about workflows. It's just a bunch of generic code here. Okay? So that is checkmark number 2, being able to create other actors. We've now covered sending and receiving messages in a couple of different ways. We've covered creating new actors. The next thing I want to cover is being able to run forever and exist forever. Now, if we refer back to how in our interface here, now I canceled this one so that I can be able to have a clean state for the final version, but when we're trying to rebuild the state for this workflow, for this actor, we end up having all of these events. So temporal is in some ways an event sourcing system where we can see the events that have come into this actor and be able to recreate things when that cluster dies, that worker dies and comes back up. We can create exactly where it left off. That's great, except that when this history gets very long, we then end up having a rather long delay in order to rebuild that. And so if it gets too long, I want to be able to clean it out and start from a fresh state so that if things die, I then have that minimum delay possible. To do that in code with temporal, in my loop here, in my blocking loop, I'm also going to add a condition of, has my history length reached a certain threshold? If that event history length has reached a certain threshold, I am going to continue as new, is a terminology that we have for clearing out the event history and starting brand new so that if things crash and have to come back up, that event history is clean and we don't have to recreate that or replay through those to rehydrate our state. Instead, that customer object is maintaining everything we need to know in terms of our loyalty points and our status so that we can come back fresh. Okay, let's look at how this works when everything's all together. I'm going to restart my my worker so that I have something running that can actually run my code. I'm going to start off that customer 123 again so that I have, we have our customer here at the member tier. I'm going to add some new loyalty points so that they're now at platinum tier. That gives me enough status to be able to invite those customers. I'm going to invite a customer ID of guest123. So I don't know, I made up the customer ID to be just that's our guest. When I do that, I get a stack trace because a demo would not be good if it didn't crash. What was our stack trace? Bear with me. Oh no, index 5 out of bounds. Index out of range. Anyways, we'll come back to that. But we can see now here that I both have the customer 123 running. I have its guest running as well. That guest status here is the one that failed. But we do have here that we tried to ensure the minimum status of gold. Guests allowed 5 is probably what's going to be causing that stack trace. I'm not going to fix that live, but we at least see that we have our child workflow started, and that's that. Now, back to our slides to summarize everything. We've learned today that we can create workflows that can receive, send, and act on messages. We have created one that can create others, even if I have an index out of bounds error. We can see that we have infinitely created, enabled them to infinitely run, and altogether that enables us to create actors as workflows, or workflows as actors. Because actors can do things, workflows can too. You combine them and you end up with a resilient and reliable actor system. If you want to learn more, my colleague Emily is doing a talk on making Saga patterns easy to implement. If you want to learn more about Temporal, you can find us there. That's where our booth is on this floor. And there we have a raffle that you can sign up for winning one of those lovely little things. And that's all I have for you today. So I'll open up for Q&A now. Thank you so much for your time. Questions of any kind? Yes? Yep, correct. Yeah, so one of the things, so the question was the workflow here that I have in the demo is maintaining its own state, particularly this customer object, with, for example, that list of guests and whatnot, and the number of points. And do I have to maintain, do I have to implement things concurrent safe? Yes and no. So the yes version of that is that I can do whatever I want in here. I can create a thread pool that I have multiple things running. I can do a whole bunch of very computationally intense computations, and if I'm doing that, let's say I'm sending multiple emails or trying to build an email in parallel via multiple threads for whatever reason, I'm going to have to implement that in all of our traditional parallelism and concurrency safe ways. That said, when I have a workflow running for customer 123, and then I create one that is running for customer ABC, those will never hit each other. Those will never conflict with each other. And so that state that customer 123 has, I can have that code modify 123 and know that it's only modifying 123. It is never going to step on ABC. Does that answer your question? Okay. Yep. Yeah, so that's where we get that concurrency for free, essentially, because we have that separation of workflows, and that's just part of the system. Yeah. Yeah, please. Yes. Yep. Yeah, that's so I did that, and I maybe went over it quickly, but that's this line right here. So that line right there is saying that, for example, customer 123, the workflow representing that customer, has created a new workflow. Let's call it ABC. And I want to send a message, I want to send some state over to that workflow, in particular, using the method called ensure minimum status with the parameter of guest min status. And that workflow can do whatever it needs to do with that information, including potentially modifying its state using this function. Now, given that I had that, I have this handle on that child workflow to signal, that's where we get our concurrent separation of these two workflows. And so even though, like objects, even though I'm calling the same method, it's going to be a completely different instance, and so then our ensure minimum status method is going to change ABC's state as directed by 123. Any other questions? Yes. Yeah, that's a good question. So let's maybe, I don't know, create 1 million of them. And that's our thing to do that with. Going to make the ID for this I, and make sure my quotes are all good. It's a brand new demo. You've never seen this before. I've never had it work. I've never done this before. So we'll see if it works. Okay. Oh, it didn't do my. What did I do wrong? Oh, you're right. That is a bummer. Yeah, I'm just gonna make them doubles. But have to escape them. Okay, so that's gonna take a bit to go. But we'll see here, my worker is happily logging out that those are being created. You'll notice as those numbers get larger, and granted this is all running locally, so it's just gonna take its time to go through this, and it's not the most efficient loop. I would rather do these in parallel, but for sake of demo that I created 2 seconds ago, we'll see that I also now in my user interface have separate workflows for all of these that are being created. They're all running perfectly fine. My machine is not slowing down. Those are being created at about the same rate. What is really happening under the hood here is that because none of these are actually doing anything, because again, that code here has at the very top of its thing this await, it is properly being able to block all those threads and yield execution back to the main thread without having to worry about actually blocking any resources. And so the server side is maintaining that. So part of that state that is being maintained here, I've got that workflow task completed. This particular workflow has nothing else to do. However, if I sent it a signal to cancel this account, it now gets a new event in this history to say, you've gotten the signal to change some state. Now that one particular workflow has to wake up and then modify its state and then check to see if that await condition has been satisfied and then do what it needs to do. Nothing else is actually running in the meantime. So the server side is maintaining the state of having all these running, and again, that's still not slowed down. And the workers are sitting there polling for, are there any workflows that have anything left to do, anything new to run? If it does, then I'll change that state and let the server know what state has changed afterwards. Does that sort of answer your question? The other answer to that question is, so if I put on my corporate hat, some of our customers have extremely large scale. For example, one of our customers is Snapchat, who does their stories using Temporal, and those are running millions, if not hundreds of millions of workflows a day. Yeah, so from a can we handle the load perspective, yes. But there's some magic under the hood that is happening to allow all of these workflows to not be consuming resources when they don't need to be. Say again? Oh, yeah, it's just, it's nice. It's like watching a project progress bar, seeing this slowly move forward. Any other questions? Yeah. Yeah, that's a very good question. So the question was, supposing, and let's just say, for example, that I changed this logic here, right? Where I say that instead of, stack overflows. Yep, we'll just hide that. So supposing that I change the logic to have the previous tier, I'd want to have it be tier +1, or they don't get that tier, and I change the logic for this, the contract that we have for how this happens. Short answer, it's a complicated thing. Long answer is there are APIs that we have in our SDK that say, I want to have a different version of this code, and I'm going to have, it is, so for my version ID of, I don't know, V1, that's the code that I'm going to do for that version, and I suppose there's other parameters that I need to put there, then I can say that for version 2, I'm going to run this other code, and then once all of my customers that have been running V1 have expired, I can remove that branch of code. I can do that, or I can say I can have my code segmented on different workers and say that this particular worker is only running my legacy code, and at the point that it has no more code to run because all of my customers have I've already migrated all my code over to version 2, then I can close that worker, but meanwhile the version 2 worker is still running. So there's a couple different design patterns that we can use to do that. Because we need to do this because when I have that series of events that I'm going through and replaying, if there's any discrepancy in the difference between what the workflow thinks it should be running versus what has run, then we can't guarantee that we're running the same code and it's going to crash out. So we need to be able to guard things with these version tags when we migrate and roll forward with our code. Yeah, you would end up getting what we call a non-determinism error. So something has changed, and so now the sequence of events that we tried to replay to get to the current state is different than what would have actually happened, and so there's a discrepancy between the event history and the code, and that throws non-determinism error, and that workflow will now die. It'll be terminated. Yeah. Oh, yep. I saw that hand and then a voice over there. Yep. Okay. Yeah. Was that hand up first? Ah, that is a good question, and yes, and um, it happens more often than you want it to happen, I'll say. Because we have to change code, right? We have to make bug fixes. We have to move forward with our code, and so at some point we will run into it again. Um, uh, Fortunately, we have, and I'll get back to your question and give you more than a one word, but we have test infrastructure that allows you to do regression tests, essentially, to say, I've made a bunch of these changes. Is it going to cause a non-determinism error? Test that locally, and then if it does, then I can properly add in the guards here that'll avoid that. So in real production terms, no, it doesn't happen ever because we want our workflows to continue running. In real development terms, it happens all the time because we need to make changes to our code. I know it's somewhat of a non-answer, but does that help a little bit? Okay. So there are ways for us to be able to say, okay, supposing that I have this one, right? This is the one that had that index out of bounds error. And I know that it happened when I tried to ensure the minimum status here. That was the last thing that successfully happened. And then something else happened in the process of handling that I didn't like. What I can do is I can, our command line interface and API, because command line interface is just a wrapper on the API, can allow me to say, reset this execution at step number 11. I know that one was the last successful one. The workflow basically terminated itself after that, so reset at number 11 and move on from there. And it'll then erase 12 through 14 and continue happily, assuming I fixed the code. So for that, I have another demo, and we're getting close to our time, but bear with me. So conveniently, this is called the bug fix demo. And here, it's a very complicated bug. We have a bug. If we have this bug, we're going to throw an error. That's it, okay? Our workflow in this case is super simple, where I just want to do 1, 2, 3. Each one of these just logs something out. So I have step 1, print something out, step 2, print something out, etc. Now I want to split. Oh god, that other one is still running, isn't it? Okay, let's stop that. What did we get to? 4,000 out of 1,000,000? Whew, okay. Let's start my worker, and I'm going to also use Gradle to start my workflow. That one. In the logs, I will see that error. So that cannot run this thing. That is that same string that is being logged in that unsupported operation here in my code. In my temporal user interface, I will go up here. I have my bug fix demo. This is now sitting at attempt number 18 of unlimited. We are automatically retrying that. You saw the code. I didn't have any retry logic in there. So it is now, I do have it set on retrying once a second with no back off. So it's just going to sit here and retry. So that's not working. So of course, we're naturally going to kill the worker and spend a lot of time fixing this bug. The bug is now fixed. I don't want to look at thread.java. I'm going to restart my worker now that I've fixed the bug, and we'll see in the logs once that 1 second has expired, second thing has happened, last one has happened, one has not happened, but that second one has happened successfully. It has now automatically retried after that second, and if I refresh, it'll appear, if I go to compact view, that nothing went wrong. It happened perfectly fine. Does that answer that part of the question? Awesome. Yes. Yeah, so one of the, I showed that how we can have a query that is going to show you the status of the customer in the workflow. So if I go to one of the customers and look at the queries, oh, I killed the worker, so it's not going to actually show. But that query is our way of asking for status from a workflow. Maybe I'll go ahead and restart that worker so we can see that. Oops. Oh. Here, let's fix that. Fix that. Start. Great. Now, so this is my query that I get here. One of the things that we automatically also get is there's a built-in query to give me the stack trace of where we are. So you can see here that we're blocked on an await happening from the customer loyalty line 41. So we can see there that that's where we're blocked. That's one of the best debugging tools that we have. From there, we also have some, we're working on a static code analyzer. We have, as I mentioned earlier, the full test suite to allow you to do unit tests and replay tests in order to see, based on a given history or a given sequence of events, how things will play out. Those will give you that part of the development workflow. And yeah, we have our stack traces here. I believe we can attach a debugger to these, yes. I've not personally tried it, to be honest. But yes, I believe we can. Because like, as you may have picked up on for my workers, I'm just running through Gradle anyways. And so those processes like we can attach to, and yep, that'll be fine. Yeah. It's workflows as actors with persistence and reliability. And so that persistence is provided for you as part of the temporal platform. So I didn't have an extra database. I just rely on temporal and whatever its persistence is. That persistence is used for this sequence of events here. That we have, and it's not persisting your data necessarily, and it's just persisting the events. And that's the only persistence that exists. Otherwise, the rest of temporal, the ability to pull down these events, pull down work only when it's necessary, replay these events to get back to recreate the state, all of that is then providing the reliability and resiliency to the actors. So it's both the persistence and the reliability. Yep. Yes. Uh-huh. Yeah, the benefit that I see the most is that this is general purpose code. I think there's no user interface. It's not a workflow as configuration. It's purely code. So this is a workflow engine designed for software engineers, for programmers to write just general purpose code. Yep. Uh-huh. Yeah, so the question is, any application is going to have a level of abstraction. In particular with object-oriented, we're going to have object managing other objects, or in actors, maybe we have actors managing other actors. For example, it's a common pattern in the actor model to have what are called, now I'm blanking on the term, other actors that are monitoring the existing actors so that we can see whether they're failing or see what they're doing. And short answer is yes. I think it is a very common pattern to have workflows managing other workflows. In particular, if you have a particular set of work that is going to take a long time or be I don't want to block on it, and I want it to just exist on its own, like create another workflow for that, and you end up with this hierarchy of workflows. For example, I showed here in the code that there's a I abandoned my child. This workflow abandoned its child. That is not the default. There's a reason I had to set it here. So our default is that we maintain those links between parents and children rather. And so that you can be able to say, one workflow can say, give me all of my children and, I don't know, send them a signal, like ensure that their status is at least gold. And so that allows me to create architectures like a fan-out processing, where I have one parent at the root of a tree that is going to deliver work to a bunch of other workflows. That is perfectly reasonable. And those workflows can do whatever they want, because also I specified that this child workflow is this customer loyalty one, which happens to be this same one. But given that I passed in this workflow, I can pass in whatever type that I want, and I can have it run something else completely as well. Does that mostly? Okay, great. I think we are more or less out of time. So again, thank you so much for being with me today. Thank you so much for your great questions. And I hope you have a great rest of JCON.